Okay, now I will work on Fall 2011 Math 227 Test 1, number 12. A deck of cards contains 52 cards. Part A, 2 cards are selected at random without replacement, one at a time. Now compute the probability that the first card is a spade and then the second card is a heart. Now notice that it is without replacement. Okay, so the probability that the first one is a spade and the second one is a heart is equals to, you don't have to show these things, but I will write it down just to explain what happened. That's equals to the probability of getting a spade first times, after you get a spade, what is the probability that you get a heart, given that the first one is a spade. Okay, now most students, when they do this problem, they don't write the first line there, they just go ahead, and I accept that answer if you think, okay, what is the probability that the first one is a spade? There are 13 spade cards out of 52 cards times, now the second card is a heart, given that the first card that you took is a spade. So how many hearts we have after you took the spade in the first one? Now there are still 13 cards, 13 heart cards, but at a time only 51 cards available. Okay, now let's see again. The first card is a spade, the probability is 13 out of 52, and then after you took the first the spade card, there are only 51 cards left, right? Now out of that 51 cards, there are 13 heart cards. Now then, if I want to compute this, I can reduce that first. This is 1/4 times 13 over 51, which is 13 over 204. Now you can leave it like that, simplified fraction, or if you change it into decimal, remember to round it to 5 decimal places. Okay, now part B, 3 cards are selected at random. Compute the probability that at least one of them is a diamond. We want to find the probability that the number of diamond cards is at least 1, right? But that's the same to say the probability that the number of diamond is not 0, right? Now what is the probability that the number of diamond is not 0, diamond cards not 0? That's the same to say 1 minus the probability that the number of diamond cards is 0, right? But if the number of diamond cards is 0, means basically it will be the rest, right? Out of these 3 cards, none of them diamond. Let me write it down that way. No diamond cards. Right? Now then, what is the probability that out of these 3 cards here, all of them not diamond? And we see if the first one is not a diamond, how many cards not a diamond? There are 52 minus 13, right? There are 39 out of 52 cards If you think about it, it's actually 3/4, right? Because we have the 4 denominations, 3 of them not diamond. And then the second one, also not a diamond, that will be 38 out of 51. And the third card, also not a diamond, will be 37 over 50. Okay, now anything after that, you use calculator. Okay, I hope you find it to be make sense. Actually, if you think about this a bit further, given that if you already learn how to do the combinatorics, we can use combination. This is equals to the probability that it is no diamond, means out of 39 non-diamond cards, you choose 3 of them, times out of 13 diamond cards you choose nothing, pick over, out of 52 cards you choose 3. Now you can do it this way if you already have learned combinations. Okay, in this case, because the cards are selected at random and it doesn't say do you do it with how to say, if you do it without replacement, then you will use combinations. If you do it with replacement, then I mean, when you pick a card and then you put it back, reshuffle it, and then pick it again, and then put it back, then the number of no diamonds, the probability of no diamond cards will not be like this. This is if you have without replacement. If we have replacement, then it will be 39 over 52 to the power of 3. Okay, but yeah, this is the questions which is not complete, and I remember I need to I told my students during the test that these cards are selected at random without replacement. Okay, now anyway, coming back here, if you compute it this way, you will see that the answers you have will be the same to what we have there. Okay, that's for